So, you know now the basics of derivatives. Now we're going to start applying it to actual useful things, okay? So the first thing we're going to do today, or in this series, is the equations of tangents. So we're going to use the first derivative of a function to find a tangent. That's our main thing today. The gradient of the tangent is the first derivative at that point. So the instantaneous rate of change. We're using, do you remember this formula? So let's have a go. So the following graph, we want to determine the equation of the tangent. So what was the two things we needed to know? The gradient and a point. So how do we find the gradient? We use the derivative. So dy dx. What's the derivative of that function? X plus 3. So this is the rate of change along that whole equation. Okay? I want the equation of the tangent at that point. So how could I now use that general form of the derivative to find the gradient at the point? Okay, so our point is where x equals 2, so we're going to sub that in. So the more specific, at x equals 2, dy dx equals 2 times 2 plus 3. So the gradient at that point is 7. Any questions so far? So I found my instantaneous rate of change, or the gradient at that point, at x equals 2 on that line. Okay, what was the other thing I needed? So I needed the gradient and I needed a point. So I've already got an x value. How am I going to find the y value at that point? Very good. So find y. So we have y equals 2 squared plus 3 times 2 plus 2. So the y is 4 plus 6 plus 2. Yay, some of us are awake. Okay, so I've got the point, I've got the gradient. What do you think's the next step? Remember that funny rule I gave you? So we're subbing it in. Usually we have an equation with what isolated? Y by itself. So I'm going to expand the brackets and then bring the 12 over. So expand the brackets and bring the 12 over. So we're left with that equation for the tangent. Does that make sense to everyone, or is there any questions? At x equals 2. Okay? Not too tricky. There's another thing we can do with all of that information. We can find this thing called the normal. So if this is the equation here, I don't know, if this is the tangent, sorry, the normal is a thing that's exactly 90 degrees to that line. Okay? This is the main thing you should write down today. The gradient of the normal is the negative reciprocal of the gradient of the tangent. Okay? Is equal to 1 over the negative tangent gradient. So it's 1 over negative 7. Okay, so same equation again. Y minus y1 equals mx minus x1. So sub in the point. We've got 12 for y. We've got the gradient, and we've got 2 equals x1 equals 2. So again, you rearrange this because we like to have the y by itself for equations. So there's your final equation for the for the normal. The equation for the normal. Is there any questions about any of that? That's pretty much all of my talking for the moment. Plus 2. So where should we start on our calculator? Get to graphs, menu, graphs. Who would have thought? And then we type in what? The equation. So let's start with the point because it's a bit easier, or at least I remember how to do it. Menu. Have you guys seen this trace function before? Yes. Yep. And what was the point that it gave us in the example? X equals 2. So we're going to find, using trace, x equals 2. There you go. So if you type in the number 2, it goes to x equals 2, and you get the y value 12. So we now know the value. So I don't know, if it was a tech active, you could just say, use trace to find y equals 12 for x equals 2. Does that make sense? So then menu, 6, analyze graph, and then see the dy dx, which is the gradient or the rate of change or the derivative. Okay? Alright, so it's asking for a position. Any guesses what the position is? 2. Let's try 2. You can see it. It said 7, so it's given me the gradient at x equals 2. I'll say it again. Menu, geometry, points and lines, tangent. You select the point where you want the tangent, and look at that. It gave us the equation for the tangent. Y equals 7x minus 2.